Right, today we're going to learn how to solve linear equations, very simple linear equations that often appear on especially the foundation GCSE paper. What you need to do is you need to observe carefully and follow the pattern of what is happening. Okay, so here we go. We'll start off with very simple equations and then we'll move on a little bit to some more complicated ones or more challenging ones. But all of them can be solved by using the pattern. So, for instance, if you have an unknown, let's call it x, but you know that if you add 5 to it, you're going to get 12. So you want to solve this equation. What it means to solve an equation is to find the value of the unknown. And in this case, the value of the unknown itself is x. We want to find the value of x. And when we've found that value of x, we will have the solution to the equation. Now, what we do is we know that if we add something, if we add 5 to this number that we don't know, we're going to get 12. So if we subtract 5 from both sides, then we'll know what the number is. So 5 take away 5 is 0, so those will cancel out, and only thing that's left is the x, and 12 take away 5 is 7. So we know the solution of this equation is 7. Now look at the next one. And in this case, we're going to have, again, we'll have an unknown. This time we're going to call it y. But this time, when you subtract 10 from the number that you don't know, your answer is going to be 30. Now, you may think that I can just do this by looking at it and I can work out the answer. The reason it's important to know the method is that you can apply it when it comes to slightly more challenging equations. So again, here we go. We know that if we take 10 away from a number, we're going to get 30. So if we add the 10 back on again, we'll know what the number is. So 10's cancel out because 10 take away 10 is 0. And we're left with y is equal to 30 plus 10, which is 40. So y is 40. So y equals 40 is the solution to this equation that we've just solved. Okay, let's try another one. This time we have, let's say p over 5 is equal to 25. Now here, the p is being divided by the 5, so we know that the p must be bigger because you have to divide it by 5 to get 25. So again, we do the opposite. Because the p is being divided by the 5, we multiply both sides by the 5 to keep the equation balanced. 5 divided by 5 is 1. So we have only 1p left. And 5 multiplied by 25, well, 4 times 5 is 25 is 100, plus another 25, so that gives us 125. So the solution to this equation is p is equal to 125. Okay, and our final example, our final method that's going to get us to the end post when we need to is, we'll choose this color. So now let's say that we have 6z is equal to 20. Now in this case, the z is being multiplied by the 6. So we need to multiply a number by 6 to get 20. So that number, if we divide it by 6, but we divide both sides by 6, the 6 and the 6 cancels down to 1, and we're left with z, and 20 divided by 6, we have 20 divided by 6. Now we can simplify this. This is an improper fraction, so we can write it as a mixed number. So we can say that z is equal to 6 and 20 goes 3 times, and 6 times 3 is 18, so there are 2 over, and then write that as a fraction. But we can simplify that's even more, because 2 over 6, 2 and 6 can both be divided by 2, so 2 divided by 2 is 1, 6 divided by 2 is 3, so 2 sixths is equal to a third. So these are the solutions to the equations. Now, it's your turn to practice some. Keep these in mind, keep our examples in mind, and try these. Okay? There's a couple of hints in the boxes to help you. And then when you've done those, then you go on to the mastery questions and then you'll be able to see the solutions. But try the mastery questions first before you actually look at the solutions. Okay, let's do some practice ones together. So, I'm going to give you a minute to think about what you should do here. Now, because the 6 is multiplying the unknown or multiplying the x, we do the opposite of that, which is divide by 6. That's right. So those 6 will cancel out. So here the x is equal to 30 divided by 6, which is 5. And that's our solution. And you can see that that was clearly a one-step solution. It took us one step to arrive at the solution. Okay, let's have a look at the next one. Here we have two parts, but we're going to look at the same. We're going to do it in the same way. So if we look up at our examples, we can see that the first thing we did was either we did the adding or the subtracting part. We did the multiplying or the dividing second, and we're going to do the same thing here. So the first thing we're going to do is we're going to, because it's subtract 7, we're going to add 7 to both sides. So those 7s would cancel out. So what are we left with? We're left with 4x is equal to 42 plus 7, which is 49. Now, here the x is being multiplied by 4, so we do the opposite, we divide by 4. Those 4's divide down to 1. So now we're left with 1x, which is equal to 49 over 4. And again, that's an improper fraction. We can write it as a mixed number. 4 into 49, or 4 into 48 goes 12 times, with 1 left over. And that's clearly a two-step problem. Let's have a look at the next one. So here, now although the x's are written after, so we've swapped it around, we have the x's written as the second term in this equation, but that's fine, we still use the same method. So here, this 10 is like a positive 10, isn't it? It's adding 10x. So we'll do the opposite. We will take away 10. Again, from both sides. 10 take away 10 is 0. So we're left with minus 3x. Remember to keep the minus together with the 3. Is equal to 40 take away 10, which is 30. Now, you can see that the x is being multiplied by minus 3, so we're going to divide both sides by minus 3. And a negative divided by a negative gives you a positive answer. So minus 3 divided by minus 3 is 1. So x is positive. And then 30 divided by minus 3, a positive number divided by a negative number, is equal to 30 divided by 3 is minus 10. So x is minus 10. That's clearly a two-step problem. Okay, keeping those in mind, please have a look at the mastery, have a go at those, and then when you're ready, have a look at the solutions at the bottom.